Today we're going to learn how to solve systems of equations using the elimination method. You should be on page 20 in your notes packet. We know that a system of equations is a set of equations with two variables that have a common value. To solve a system of equations using the elimination method, we must eliminate a variable. To be able to do this, the variables must form a zero pair. So, for example, if you have a system of equations and you have 3x plus 2y equals 5, and then you also have negative 3x plus 8y equals 12. What you can see is that you have a positive 3x here and a negative 3x here. Well, together, those would make 0 if I added them. So because of that, what I can do is add both equations together. Let's look at our first example. You see negative 5x minus 6y equals 8. And you also have the equation 5x plus 2y equals 4. We can see that we need to figure out the value of both x and y. So we start by looking in our equations and seeing if we have any coefficients that are zero pairs. Well, I notice that my coefficient on x is negative 5 in my first equation, and my coefficient on x is positive 5 in my second equation. I know that those are zero pairs, and I know that together they would equal 0 if I added them. So what I'm going to do is add both of these equations. What you'll notice is that if I add negative 5x plus positive 5x, they will eliminate or cancel each other out. Then what I'm left with is negative 6y, and we need to be careful and notice this minus sign, which tells me that this is a negative 6y, plus positive 2y. Well, negative 6y plus positive 2y would give me negative 4y. I also need to add this part of my equation as well. So we have 8 plus 4, which gives us 12. Well, now we're left with an equation that only has one variable, and we can solve for y. To get y by itself, I would get rid of my negative 4. So we see that negative 4 is being multiplied here, so we'll do the inverse, which is dividing by negative 4 on both sides. These will cancel to leave us with y equals, and then positive 12 divided by negative 4 is negative 3. Now, we're not finished because the solution to a system of equations is going to be the value of both variables. So now that we found y, we are going to use that to tell us the value of x. Now, to figure out what x equals, I need to use one of my equations, and it doesn't matter which one. I typically just use my first equation. So my first equation says negative 5x minus 6y equals 8. Well, again, we don't know what x equals, but we've done the work to figure out that y is negative 3. So I can take that and I can substitute it in for y in this equation. So this is going to say negative 5x minus 6 times y, but we know that y is negative 3, and all of this equals 8. Well, we need to simplify this, so there's nothing that we can do with negative 5x. We're just going to rewrite it. But we do see negative 6, and we have to be very careful because, yes, that is a negative. Negative 6 times negative 3. Well, negative 6 times negative 3 gives us positive 18. You need to be extremely careful here. Since the value is positive, we need to write plus 18. We're not just copying down subtraction symbols all the way. Symbols tell us whether something is positive or negative. So since we multiplied negative 6 times negative 3 and we got a positive 18, we need to have a plus sign right here. Then we still have all of this equal to 8. Now we have an equation that can be solved. We know that to solve this equation, We need to eliminate our 18 first. So 18 is being added, so we're going to do the inverse, which is subtracting 18 from both sides of our equation. Our 18s will cancel to leave us with negative 5x equals. Then we have 8 minus 18, which gives us negative 10. Now, the last thing we have to do to get x by itself is to get rid of this negative 5. So since negative 5 is being multiplied by x, we're going to do the inverse, which is dividing by negative 5 on both sides of our equation. These will cancel to leave us with x equals, and negative 10 divided by negative 5 gives us positive 2. Now, we know that the value of x is positive 2, and the value of y is negative 3. Whenever you have a system of equations and you are finding x and y, which is typically what you're doing unless you're looking at real-world problems, you want to show that as an ordered pair that goes together. Well, you need to remember that ordered pairs are always in parentheses with the x value first, followed by a comma, then the y value second. Well, we know that x is 2, so I'm going to start my ordered pair with 2. And y is negative 3, so I'm going to put negative 3 in the y place. So my solution is the ordered pair that tells me the value of both x and y. My next equation says 6x minus 4y equals 14, and negative 3x plus 4y equals 1. Well, I'm looking for coefficients on variables that are zero pairs. Well, my x values have a coefficient of positive 6 and negative 3, which are not zero pairs. So I'm going to look at my y values. My y values have an order or coefficients of negative 4 and positive 4. Those are zero pairs. I can add negative 4 plus positive 4 and get 0. So that means that I'm adding both of these equations together. If I add 6x plus negative 3x, I'm going to get positive 3x. If I add negative 4y plus positive 4y, I'm going to get 0. So they will eliminate each other, and I'm left with my equal sign. Then I'll add 14 plus 1, which gives me 15. Now I just need to solve for x by getting rid of my 3. So I'm going to divide by 3 on both sides of this equation. My 3's will cancel to leave me with x equals, and then 15 divided by 3 is 5. So that means that my x value is 5. Now we're going to take that and plug it into one of these equations. And like I said, I usually just choose the first one, but it doesn't matter which one you choose. If I use my first equation, I have 6x minus 4y equals 14. Well, I'm going to take x and I'm going to plug in 5. So this is 6 times 5, then minus 4y equals 14. Well, 6 times 5 is 30, so my equation says 30 minus 4y equals 14. Now, this equation can be solved. I know that I need to eliminate this 30. I see that this is a positive 30, so the inverse of that is a negative 30, which means I'm going to subtract 30 from both sides of the equation. 30 minus 30 will cancel. What I'm left with is not 4y, but it's actually a minus 4y, which means that I'm left with negative 4y. Then I have 14 minus 30, which gives us negative 16. Next, I need to get y by itself, so I'm going to divide by negative 4 on both sides of this equation. My negative 4's will cancel to leave me with y equals, and negative 16 divided by negative 4 gives us positive 4. That means that the solution to my equation is that x is 5 when y is 4. So my solution is the ordered pair 5, 4. Now example 3 says 4x plus 3y equals 2, and 5x plus 3y equals negative 2. Well, when I look at my coefficients, I have positive 4 and positive 5, which are not zero pairs. Then I also have positive 3 and positive 3. Again, those are not zero pairs. But what I can do here, instead of adding, is that if I have a coefficient that is exactly the same, I can subtract both equations from each other. So let's subtract this entire equation. If I do 4x minus 5x, 4 minus 5 is negative 1, so this is like saying negative 1x. 3y minus 3y is 0, so those will cancel each other out, and then I have my equal sign. Now you have to be careful with your negatives, especially when you're subtracting. 2 minus negative 2 gives us positive 4. Now we just have to get x by itself. X is with this negative 1, so we need to divide by negative 1 on both sides of our equation. These will cancel and leave us with x equals positive 4 divided by negative 1 gives us negative 4, so our x value is negative 4. Now we need to find y, so we're going to take one of our equations, and again, I just like to use my first one. So it's 4x plus 3y equals 2. Instead of x, I'm going to plug in negative 4. So this is 4 times negative 4 plus 3y equals 2. 4 times negative 4 is negative 16, and then I have plus 3y equals 2. Well, I need to get y by itself, so I need to eliminate this negative 16 first. Well, that's a minus 16, so the opposite of that is plus 16, so I will add 16 on both sides of this equation. Negative 16 plus positive 16 is 0, so those cancel out, and I'm going to bring down 3y equals, then 2 plus 16 gives me 18. Now, to get y by itself, I need to get rid of my 3, so I will divide by 3 on both sides of my equation. My 3's cancel to leave me with y equals, and 18 divided by 3 is 6, so my y value is 6. That means that my ordered pair is that x is negative 4 when y is 6. Example 4 says 5x plus 6y equals 50, and negative x plus 6y equals 26. Well, when I look at my coefficients, I don't see any coefficients that are zero pairs, but I do see identical coefficients. I have positive 6y and another positive 6y. So instead of adding those, I can subtract this entire equation. Well, this is 5x minus negative x. Remember that even though you don't see it, there's an invisible negative 1 there. So this is like saying 5 minus negative 1. Well, again, you want to be careful when you're subtracting with negatives. 5x minus negative 1x gives us positive 6x. When I do 6y minus 6y, that's 0, so they cancel each other out, and I'm left with an equal sign. Then I'm going to subtract 50 minus 26, which gives me 24. Now I have an equation that says 6x equals 24. So to get x by itself, I'm just going to divide by 6 on both sides. I'll be left with x equals, and then 24 divided by 6 is 4. So my x value is 4. Now I'm going to take that and plug that into one of my equations. So if I use my first one, that says 5x plus 6y equals 50. I'm going to plug that in for x, so 5 times 4 plus 6y equals 50. Well, 5 times 4 gives us 20, so we have 20 plus 6y equals 50. And we want to get y by itself, so we're going to get rid of our 20 first. That's a positive 20, so the inverse is negative or minus 20 on both sides. Then we're left with 6y equals, and 50 minus 20 gives us 30. Now, to get y by itself, we are going to divide by 6 on both sides of our equation. We'll be left with y equals, and 30 divided by 6 is 5. So we can see that our solution is that x is 4 when y is 5. Now, sometimes we do not have 0 pairs when we are eliminating. So what we have to do instead is create an equation that is equivalent. In this equation, you see that we have a positive 3 and a negative 1 for my coefficients on x. You can also see that I have a negative 2 and a positive 1 on my coefficients for y. In this situation, what you see is that I don't have 0 pairs or identical coefficients. So what I can do instead is find a coefficient that is positive and one that is negative. Well, I see that my x has a positive 3 coefficient and a negative 1 coefficient. Well, I know that if I multiply negative 1 times 3, I'm going to get 3. So what I'm going to do here is multiply this entire equation by 3. Now remember, you're multiplying the whole equation, so we would actually be distributing this 3 everywhere in the equation. Well, 3 times negative 1x gives me negative 3x. Then 3 times positive y gives us positive 3y, so we would write plus 3y. You have to remember that you're even multiplying the 3 by this 1. So 3 times 1 gives us 3. Now what we can do is use this equation and this equation. Because this equation is equal to this, it has just been multiplied. Well, what I see is that I have a positive 3 as a coefficient on x and a negative 3 as a coefficient on x, so I'm going to add both of these equations. Well, 3x plus negative 3x is 0, so those will cancel each other out. Then we have to be careful because this is not 2y, but it's actually negative 2y. When we add negative 2y plus positive 3y, we get positive 1y, which is just y. Then we have 3 plus 3, which gives us 6. Well, that tells us that our y value is 6. Now we can use that to find x. So we're going to use our first equation, which was 3x minus 2y equals 3. And we're going to plug in 6 for y. Well, that's 3x minus 2 times y, but we know that y is 6. So we're left with 3x, which we haven't done anything with, but we're going to do negative 2 minus 6, or times 6. Negative 2 times 6 gives us negative 12, so we'll write minus 12 and then equals 3. Now we just have an equation that we can solve using inverse operations. We're going to get rid of our minus 12 first by adding 12 on both sides of our equation. Our negative 12s cancel to leave us with 3x equals, and then 3 plus 12 gives us 15. Then we're going to get rid of our x, so we can, or our 3, so that we can get x by itself. So we're going to divide by 3 on both sides of this equation. Then we're left with x equals 15 divided by 3, which is 5. So we can see that our x value is 5 when our y value is 6. Example 6 says 2x plus 5y equals 3, and 3x plus 10y equals negative 3. Well, we can see that we don't have any coefficients that are 0 pairs or the same, and we also don't have any coefficients that are opposites because we have a positive coefficient for x and positive coefficients for y. But we can fix this. What we can see here is that we have a 5 as a coefficient on y and a 10 as a coefficient on y over here. Well, I know that if I multiplied 5 times 2, I would get 10. So if I want to get a 0 pair, I can take this first equation and instead of multiplying by 2, I can multiply by negative 2. Now, if I multiply by negative 2, remember I want to multiply everything in the equation by that negative 2. Negative 2 times positive 2x would give us negative 4x. Negative 2 times positive 5y would give us negative 10y. Because it's negative, we would write minus 10y. Then negative 2 times positive 3 would give us negative 6. So now we're going to use this new equation with this equation, and we can find that we have a zero pair. We have negative 10y and positive 10y. So because we have a zero pair, we can add those together. Well, negative 4x plus positive 3x gives us negative 1x. Then negative 10y plus positive 10y is 0, so those will cancel. And next we have negative 6 plus negative 3. Well, negative 6 plus negative 3 gives us negative 9. Now, x is not by itself because it's still being multiplied by negative 1. So we would do the inverse, which is dividing by negative 1 on both sides. Well, that would leave us with x equals, and then negative 9 divided by negative 1 is positive 9. So we know that our x value is positive 9. Now we can use that to find our y value. So if I go back to my first equation, that was originally 2x plus 5y equals 3. I can plug in 9 for x. So this is 2 times 9 plus 5y equals 3. Well, 2 times 9 is 18. So I have 18 plus 5y equals 3. Now to get y by itself, I need to get rid of my 18 first. That's a positive 18, so I'm going to do negative or minus 18 on both sides of this equation. My 18s will cancel to leave me with 5y equals, and then 3 minus 18 is negative 15. Now I need to get y by itself still, so I need to divide by 5 on both sides of the equation. These will cancel to leave us with y equals, and negative 15 divided by positive 5 is negative 3. So my y value is negative 3 when my x value is 9. So I need to make sure I write it as x first, y second. Example 7 says 4x plus 5y equals 35, and negative 3x plus 2y equals negative 9. Well, again, I don't have any coefficients that are opposites, but I can see that I have a 4 and a negative 3. Well, this is a positive 4 and a negative 3. Now, those are not the same, and I cannot multiply negative 3 by something or 4 by something to get negative 3. Sometimes you'll have cases like this where it's going to benefit you to multiply both equations by something. If I think about 4 and 3, I know that they have a multiple of 12 in common. So if I needed to get 4 to be 12, I would multiply by 3. So I'm going to multiply this first equation by 3. Well, 3 times 4x is 12x. 3 times 5y is positive 15y. And 3 times 35 is 105. Now, that doesn't really help me unless I also multiply this second equation. I know that I can multiply 3 times 4 to get 12 also. Now, in this case, because my 3 was negative, it's going to help me make a zero pair. So I'm going to do 4 times negative 3x, which is negative 12x. Then 4 times positive 2y, which is positive 8y. Then 4 times negative 9, which is negative 36. And I'm going to use these two equations to solve my system. Well, I can see that I have a positive 12x and a negative 12x. Since those are zero pairs, I'm going to add these two equations together. Well, 12x plus negative 12x is 0, so they will cancel each other out. 15y plus 8y gives me 23y. Then I would add 105 plus negative 36. If I add positive 105 plus negative 36, I get positive 69. Now I still need to get y by itself, and it's being multiplied by 23. So I'm going to divide by 23 on both sides of this equation. These 23s will cancel to leave me with y equals, And then 69 divided by 23 gives me 3. So now I know that the value of y is 3. And I can take that and I can put it into my equation. Well, my original equation was 4x plus 5y equals 35. Now I'm going to plug that in to my equation for y. 4x plus 5 times y, which is 3, equals 35. 4x plus 5 times 3 is 15. Now we're going to get x by itself by getting rid of our 15. So we'll use the inverse, which is subtracting 15 from both sides. These will cancel to leave us with 4x equals 35 minus 15 is 20. Now to get x by itself, we're going to divide by 4 on both sides. Our 4's will cancel to leave us with x, and 20 divided by 4 is 5. So we can see that we have an x value of 5 when our y value is 3. Now our last equation says 8x plus 14y equals 4, and negative 6x minus 7y equals negative 10. Well, when I'm looking at this, I know that I have a positive 14 on y and a negative 7 on this y. Now, those are not zero pairs, but I know that I can multiply 7 by 2 to get 14. So I'm going to multiply this second equation by 2. Well, I'm going to multiply everything in that equation by 2. So I'm going to start with 2 times negative 6x, which is negative 12x. Then 2 times negative 7y, which is negative 14y. Then 2 times negative 10, which is negative 20. Now I'm going to take this first equation and this equation, and I'm going to use those to solve. Well, I see that I have a zero pair because I have a positive 14y in my first equation and a negative 14y in my second equation, which means that I can add these two equations together. So I'm going to start by doing 8x plus negative 12x. 8x plus negative 12x gives us negative 4x. Then I have positive 14y plus negative 14y. Well, that gives us 0, so they will cancel each other out. Then I have positive 4 plus negative 20. Positive 4 plus negative 20 gives me negative 16. Now, to get x by itself, I'm going to divide by negative 4 on both sides of our equation. My negative 4's will cancel to leave me with x equals, and then negative 16 divided by negative 4 gives me positive 4. So I know that my x value is positive 4. I'm going to take my first equation, which was 8x plus 14y equals 4, and I'm going to plug in 4 for x. So 8 times 4 plus 14y equals 4. 8 times 4 is 32, plus 14y equals 4. I want to eliminate my 32, so I'm going to subtract 32 from both sides of this equation. That leaves me with 14y equals, and positive 4 minus 32 gives me negative 28. Then I just need to divide by 14 on both sides of this equation. I'm left with y equals, and negative 28 divided by positive 14 is negative 2. So the solution for this is that when x is 4, y is negative 2.